Thank you all for taking the time to join us here. Hope you are having a very engaging conference thus far. So today we are going to talk about AT&T's journey on Databricks and specifically to our serverless offerings. As you might have heard from our keynotes, we are going all in on serverless. AT&T, as you can imagine, is a fairly regulated and enterprise who processes data at scale. And so it is particularly challenging for them to adopt any new platforms. And the goal of this presentation is to explain what it takes and how AT&T has gone about their journey all the way till serverless. So quick statement here, it's a standard disclaimer that anything that we talk about is for informational. We are not making any specific commitments towards the product as with whatever we present here. So we'll start by just introducing ourselves. JP?
My name is JP. I'm part of AT&T Chief Data Office. My responsibility including scalable compute platforms in AT&T. Today we are actually going to talk about serverless in depth, our adoption of serverless DB SQL, and to an extent, serverless model serving.
Thanks, JP. I'm Samrat Ray. I lead product management for what we call as enterprise security at Databricks, which effectively includes security of our serverless platform, network security, encryption, data protection, privacy, working closely with the broader Unity Catalog team on the overall data security portfolio. Prior to Databricks, I spent a significant amount of time at Google where I had a lot of experience launching large-scale security as well as storage products while I was there. So with that, I'll hand it over to JP to start talking about AT&T's journey. Thank you.
All right. Thank you. So AT&T's data transformation journey started in the year 2019 when AT&T signed a landmark agreement with Microsoft to adopt Azure Cloud. Our goal always has been, and even today, even prior to that cloud migration, to empower data teams with democratization of data, right? So one, we want to drive AI and ML efforts at scale. That actually was a limiting options with Hadoop as a platform previously we handled. So with the cloud migration, we actually realized there is huge opportunities for us to improve that, our delivery, particularly for data science world actually. Today, our adoption in the cloud has grown significantly. We ingest hundreds of terabytes of data per day and manage over 70 petabytes of data. This is just, I'm talking about Chief Data Office alone. So our actual migration started only in the year 2020 or end of the year 2020 because AT&T has got a stringent security process. Every service that we adopt has to go through a security review process before it's accepted for adoption of our applications, right? So even Databricks went through it significantly and before it got accepted. So we as Chief Data Office, we are coming from Hadoop world. We actually owned and managed multiple Hadoop clusters on-prem. One of the largest clusters we have listed here. We were actually looking at migrating our Hadoop clusters, not only the clusters and the data along with that, right? So we were responsible for Hadoop as a technology for entire AT&T. So the responsibility is not just to migrate our applications to show the direction for the rest of the people to follow through. I mean, there's hundreds of Hadoop clusters that are running in on-prem. So when you're talking about Hadoop clusters, we are talking about variety of workloads in Hadoop clusters. Every element in the Hadoop ecosystem was pretty much used. If you're talking about HBase, Hive, MapReduce, Scala, Spark, Python, PySpark, every element was significantly used. So what is the right platform when we go from cloud to on-prem to the cloud? So our challenge is to finding the right platform and minimizing the development effort required. So when we looked at it in the cloud, we are objectively assessing every other possible platform. So one, Hadoop offerings in the cloud as well. And we also even at one point of time considered lift and shift of our on-prem Hadoop environment. If you looked at the previous slide, if you for a second One of the largest Hadoop clusters listed here at 1,300 nodes, 13 petabytes of data, and more than 2,000 users, variety of workloads, and significant number of jobs per day, 50,000 plus jobs. So it was a huge challenge for us to just migrate anything over from on-prem to the cloud. So when we looked at it objectively, all of these options on Hadoop as a service, Hadoop offerings in the cloud, each of them had their own merits and demerits. So we never actually considered Databricks as an option at that point of time. It just, eventually it fell through, right? So we started evaluating everything and somebody said, okay, let's take a look at Databricks as well. So when we objectively looked at it, we didn't think Databricks numbers were true. When we started doing benchmarking, the numbers were so good, we had to run this benchmarking effort several times. So it offered the best price to performance ratio of any of the evaluation objective benchmarking we did. So with the help, that's where our association with Databricks started. With the help from Databricks and Microsoft, we migrated multiple Hadoop clusters from on-prem to the cloud. So if you talk about high return on investment with OpEx savings, you can, I don't want to give the numbers. We also at least 3x delivery of faster delivery on ML data science efforts. Why is that? Because on-prem you always are, it's a rate of diminishing return. As you start growing up, the Hadoop cluster starts widening up. We had 1,300 nodes. Now any other increment you do, physical service you add, you get a very minuscule improvements. So you have to make a huge investment in order to get any gains. So that actually was a huge limiting factor. So today, our Hadoop footprint has grown, has completely evaporated, almost evaporated, and Databricks footprint has grown quite significantly. So in the cloud, we have closer to 100 ML models in production across different business units. Sales, you talk about finance, and we actually, what we do, we take the Lakehouse format, we take data from multiple sources and apply our models, ML models on top of it to derive real-time alerts, right? One of them is fraud ML alerting, right? So that's actually one of our VPs who's handling that is here. So essentially, it's helped us save quite a significant number of frauds, I mean, cell phone frauds and theft. So that's one example of what we have applied, how we have applied Databricks. So if you are that happy, then why? Why are you searching for more serverless? So it is not actually happiness a relative state of mind. We started looking into multiple options, but as we are actually scaling up, we do run into some kind of limitations as well, even in the cloud. So if we bucketize our challenges, there are two challenges. One is scale challenge, the other one is operational challenge. So what is the scale challenge? We don't encounter scale challenge in every workspace or every subscription. There are subscriptions where workspaces that handle quite significantly large amounts of petabytes of data at one time, large scale. When the data is large amounts of data is retrieved, we do actually experience bandwidth restrictions. What we do in those situations, we look at it specifically when there is resource throttling happening, bandwidth throttling happening. We work with our partners, Microsoft and Databricks, to fine-tune the environment. It's a soft limit. But again, we have actually specifically certain use cases, we have tuned it, and we have solved the problem. But again, those are some of the limits. On the other side, there are some workspaces where thousands of VMs are spun up within a short period of time. Usually the cloud providers put some kind of restrictions when that kind of happens, so to do resource throttling. So specifically, those are event triggered or scheduled, previously scheduled. So when those things collide, the number of VMs being spun up is significantly larger, leading to some kind of resource throttling as well. So there are workarounds with it. So by means you can partition your jobs, by means of moving into different subscription, we can resolve it. But we do experience scale issues in a very small scale, not for every job. Our biggest challenge is operational challenge. So what does that mean? Databricks in the cloud offers greatest flexibility of any scalable computing platform we are using today. When you're talking about flexibility, you can choose the VM SKUs, compute optimized, storage optimized, memory optimized. So when this kind of flexibility is available, people tend to actually choose the one that actually probably suboptimal. That's very common. Probably cost overruns is a very common issue most people are experiencing. So our adoption is across multiple functions, ELT, AML, SQL, data visualization. A lot of those functions are being handled by Databricks jobs today. And we are constantly experiencing cost overruns because developers are always challenged with time for delivery. So when they do get challenged for time delivery, the last thing they're worried about is, hey, can I tune this cluster optimally? They just want the largest VM size and largest cluster size as well. So what we do effectively when there's a cost overrun, we look at Overwatch data and marry with some other data actually we have, and we actually develop insights and reach out to individual customers and units and fine-tune their applications and clusters. This is a constant iterative exercise we go through. It's cyclical and also interrupt-driven as well. Because if you see a significant cost, shooting up with some of the workspaces or subscription, we reach out, we look at their workloads and analyze it and do it. This is operational overhead. Right around the time frame is when Databricks announced serverless. So it piqued our interest because serverless actually doesn't really actually have this operational challenges. So now question is, we operate at scale. We are looking for efficiency. We are also looking at the most important element is the security. When you talk about serverless, can it meet AT&T scale? Because we do spin up quite a significant number of VMs at any given point of time. What about efficiency? How is it compared to the existing classic offerings? Does it improve the efficiency? And most importantly, efficiency-wise, what is the efficiency it offers? And security-wise, how does it compare with the existing ones? Because when you talk about serverless, the VMs now are not running in AT&T managed VNets. They're running in Databricks managed VNets. How secure can it be? So those are some of the questions we came up with, right? So we started evaluating that. So when we started looking at the VNets, what kind of egress control they have? So can they scale? So in our objective benchmarking, that again, we did this with TCPDS data as well as our own data, there is significant improvement in terms of performance. Because the VMs are running in Databricks managed plane and they're paying for it when it's not being used, they're a lot more conservative actually in terms of killing it. When the job ends, they're more interested in killing it because they're paying for the cost of an idle VM. It's a lot efficient, we notice that. And predictive I/O on top of it, it's adding to performance gains as well. We've noticed that. I don't want to share the numbers. We also, when we did the benchmarking, we compared not only the classic DB SQL, we compared with other competing vendors as well. So the numbers were at par, or in some cases, even better. So serverless offerings. Cost-wise, we found that to be much significantly cheaper. Again, I don't want to share the numbers. So one, auto scaling, can it scale? With the limited scaling test we did, our adoption has just started. Significant scaling challenge. Resource throttling is never experienced. We actually increased the number of loads in the limited testing and saw that is there any kind of resource throttling we would experience. So far in our tests, there's no resource throttling. One of the reasons why there is no resource throttling is because the VMs are always in warm standby. You don't have to make API calls to spin up the VMs. So it doesn't matter how many VMs you spin up, we haven't encountered any of those so far. That's my claim. So, low latency startup. So one of the use cases ideally we can start applying is, today, if you're talking about the certain kind of workloads, you're talking about BI workloads. Most of the people probably want to give a SQL endpoint. If the cluster is not up and running all the time, if you want to connect to be a SQL endpoint, there's a cluster startup time that takes, and your BI tools like Power BI, right, or Excel or Tableau, they will time out first. You may have to retry multiple times before you can connect because there is a startup time that's required. That is not predictable. Sometimes, particularly in a contentious network, it's not predictable. So with serverless, that is instantly solved for us. Because it's ephemeral, we can straight away recommend that to anybody actually. Hey, if you're actually having BI tool and you need to connect, use serverless SQL endpoint. Here's what it is. Here's where you need to connect. So there is no failure in those cases. People don't have to retry. And also we have some use cases where the startup time, because a triggered job, let's say it's an event triggered job. So those event triggered job require certain startup time to be predictable. If you don't process within 5 minutes or 3 minutes, it's useless at that point of time. So those kind of things, straight away we can adopt serverless. So faster onboarding of new teams and workloads, because you don't have to say, hey, is this VM, what kind of VM, what's the cluster size, what's the SKU, all of those things are taken away with serverless. So great operational change. In our testing so far, again, the benchmarking numbers, I'm not sharing this, I can privately share that. We have seen 30 to 40% efficiency improvement in operating our platform with Databricks Serverless. So what about security? So AT&T, we are a regulated telco. Security is our primary focus. How can we mitigate the risk? I mean, talking about egress, the VMs are running in their compute plane and Databricks compute plane, how secure it is. So all those questions have been answered when we evaluated this. To talk about in detail, I'll invite Samrat from Databricks.
Thanks, JP. I don't know if the microphone is on. Oh, okay, thank you. Thanks, JP. So we'll talk a bit about how does Databricks Serverless implement defense in depth, right? So JP just talked about serverless being able to, meet their scale as well as efficiency requirements, and particularly not just meet, but they're seeing a good amount, like 30 to 40% efficiency gains. That's awesome, but if you cannot meet security, then a customer like AT&T, even despite the efficiency gains, cannot adopt the platform, right? So this was a key conversation that we partnered on and said, how do we help AT&T meet their security requirements? So think of it at a super high level, a 30,000-foot view of our serverless architecture and what it looks like. So you've got users and clients that talk to effectively what we call a control plane, but it's basically an API and web app sort of front end, which then talks to some form of compute. It can talk to Classic, which is on your right-hand top, or it can talk to serverless, that's right below the control plane over there. So now here we're talking about the serverless compute in particular. And then the serverless compute will then go back and talk to your resources. So you can bring your own storage, right? So it talks to your blob store or S3, or maybe there's something on the internet. Maybe you're talking to salesforce.com, right? So this is the sort of architecture. So how do we secure this environment, particularly when your VMs move from that the top right-hand corner, which is a Classic, which was a dedicated network that you had, and your infrastructure admins could configure things like egress control that JP was talking about, or even ingress control, to effectively a multi-tenant serverless network, right? And you can imagine it's not just AT&T, but any large enterprise customer we talk to have a requirement that their workloads are isolated. Data exfiltration, data breaches are a key concern. They've always been a key concern. Of course, they've been in the news lately, but even before that, they've always been a key concern for large enterprises. So how do we mitigate such risks? So let's look at this systematically through each of those wires that we talked about, right? Each of those connections. So the first one is your users, or maybe BI clients like JP was talking about, connecting into Databricks, right? For each of these layers, in order to meet the stringent security requirements that we see from many of our customers, we have provided a defense in depth approach. So over here, the first thing we recommend is that we look at it at two levels, right? What is happening at authentication time, and how do we mitigate authentication risks, like where you can have attacks for phishing attacks and those kind of things. And second is, how do you mitigate token replay risks, which happens at authorization or at access time, right? And for each of these, we are providing controls, The first one, at authentication time, we provide the ability for you to configure multi-factor authentication. So you can, if you're using any IDP like Entra or Okta, you can configure multi-factor authentication, and you can enable this at the account console just once for unified login across workspaces. This simplifies the thing for you. You don't have to go identity by identity or workspace by workspace and determine how to authenticate. It's just one single policy that you have there. Now you've got authentication addressed, but what about access? And also this multi-factor authentication works for users. What about access using service principals, right? So that's where we provide the ability for you to lock down your access, or another way to put that is lock down from where your clients can present access tokens to only authorized networks, right? And there are two primitives that we provide there. The first is the ability for you to configure a private link to a workspace. When you configure a private link to a workspace, you can have private access from your corporate network. You can require your users to basically always be accessing via a corporate network. So if the access token was stolen, then there's another bar for somebody like an attacker to cross, which is they have to be on your network, right? And then gain access. In cases where you must provide access over the internet, we also allow you to configure IP ACL, so you can lock it down to specific IP addresses from where such accesses can be enabled. So that was the first surface. Now let's look at it. That particular surface wasn't serverless specific, so I just wanted to cover that first, but it's pretty key because it's the entry point into Databricks. But now we talk about serverless specific surface areas to secure. And there are three surface areas you have to think about from a serverless perspective. The first one is on-network access. This is very important from a serverless perspective because we are on a multi-tenant network. When you are on a dedicated network, the first column is actually not that important because it's your network. It's pretty dedicated to you. But here, how do we address on-network access on the multi-tenant network, right? How do we isolate your workloads? The second is cloud storage access. Earlier, you had your dedicated network, so you could configure your gateways yourself, and you could grant access to your storage, and you know from your storage perspective, hey, this is my network, and you can open up your storage firewall or S3 policies in order to grant access. How do you do this now, again, from the serverless environment? And the third is internet access. So again, here you had an egress firewall. You would have blocked off internet access or granted access selectively based upon the exact locations where you want to, if you want to gain access to, like for example, Salesforce. How do you do this again in a multi-tenant environment? So let's talk about each of these surface areas. So the first one, the on-network access. So when we think of on-network access, there are two on-network accesses. One is access between the VMs on the network, and second is access from your workloads to the Databricks APIs or control plane in order to, for your workloads to operate correctly. So our goal here is to make sure that your workloads within the logical cluster of a serverless can talk to each other, but they can never talk to anything else, and nobody else can talk to you in the network. So the first principle that we apply there is we provide dedicated VMs to you, so that your VMs are not shared across tenants. The VMs themselves are not multi-tenant. And so that is the first principle. The second principle is these VMs are always isolated from the internet from an inbound perspective. Like there's no access to those VMs from the internet, right? And these VMs within the network are segmented in your specific, your VMs for what constitutes a workload or a cluster effectively are segmented out using network level security groups, right? So in Azure, you could call them NSG or security groups on AWS. They're isolated. So initially, when they are in that unallocated pool on the top, those VMs have no network access, no authority on the network, right? When you submit a job or a SQL query, those VMs get added to one of these dedicated compute boxes under, say, workload 1, right? At that point in time, those VMs can talk to each other within that box. And now they have got some network access, but only as determined by the security group. Outside of that, they cannot talk to any other workload and vice versa. So the compromise of one tenant cannot impact the other one. But we haven't stopped there. Beyond the network level isolation, we provide on-VM isolation as well. So all VM communication must authenticate their workspace ID, and if they don't have the right workspace ID, then we deny access on VM as well. So we have multi-layer protection over there to ensure that you get strong isolation on our network. The second thing is accessing the control plane. Similar to on-network access, we again use multiple layers of authentication and isolation to guarantee that access tokens being presented to our workspace APIs are presented from the right network and from the right workspace, so from your workloads. And to do that, we use a private link between the data plane and control plane, so we know it's coming from the right network. And then every workspace is strongly authenticated with client certificates as well as tokens to ensure there is no workspace impersonation that is happening, right? And a compromise of a workload doesn't imply compromise of these certificates, so we can always attest strongly that it is coming from the right workspace. So now to one of the more complicated challenges, which is how do you secure access to storage? And before we talk about what we do, it's important to understand the kind of problems that we are solving. When we talk about data exfiltration, JP mentioned that as a key concern. What does it actually mean in the context of storage? The few things it means. One, the very basic thing is, sure, your cloud storage service should not be accessible from random networks. Now that we're talking about serverless, it can not be, hey, because I want to grant access to serverless, I grant access to the whole internet, right, from a networking perspective. Clearly, that's not something you want. But even within the serverless world, you want to know that it is your workload or your workspace that can access your data, not somebody else's workload on the same network. The second thing you want to know is that your workload can only talk to your storage and they cannot write to some other storage. So in the case your workload is somehow compromised or whether it's accidental or malicious, you cannot be writing to some random storage bucket out there, right? So those are the key requirements that can be derived from the concern of data exfiltration. So how do we solve for this? Again, here we have multi-layer protection. So the first layer that we have is Unity Catalog, and this is very important, and why we keep insisting that please adopt Unity Catalog, move to this, is relative to all other solutions, Unity Catalog provides significant credential protection capabilities. So one of the key reasons, why is credential protection important? It's important to ensure that there are no replay attacks with those credentials, right? And the first thing that Unity Catalog does is instead of using your user credential to access storage, it instead authenticates you, authorizes you to see what do you have access to and issues a scoped down token. It's scoped down in time and it's scoped down to what it can access. And these tokens correspond to, say, if you're on Azure, to a managed identity that you have configured for that catalog. So they're not your user identity. So if your user identity is, let's say, compromised, your storage buckets, ACL should not allow access directly from users. So therefore, your user identity compromise does not equate to somebody being able to access your storage directly, right? And your let's say if you're on Azure, your managed identity is tied to an access connector object. So it's not something that you can just pull out and use somewhere else. It's explicitly tied to, can only be used within the context of Unity Catalog, right? So that's very important. The last point I want to make is these tokens are not accessible to user code by default, right? So when we say that Unity Catalog issues these tokens, they issue the token, for example, in the context of DB SQL to the SQL engine, not to your UDF, right? And this property remains true even as you move to notebooks or Spark jobs. That's at the credential level or the application level. The next level that we provide the security is at the network level. So the first thing that we do from a network level perspective is we block off access to storage that is not on your Unity Catalog. Defined in your Unity Catalog, or if you're using DBFS or HMS, then they have to be a DBFS or HMS path that you have explicitly configured. If it is not, then it is automatically denied. So your egress control is to storage, it's sort of baked in that way, right? Of course, all access is over the cloud provider's network and is TLS encrypted. And on Azure, I know because it's very common on Azure to use private link when you have your storage and you have requirements that you can only access data over private link. We provide a dedicated private link, so that adds defense in depth. So we've already providing the necessary level of security even without private link, and that is true on all cloud platforms. But if you do want to bring private link, for example, for particularly on Azure, we provide that as well. So the last point is about internet. What happens to the internet? And do these storage controls continue to exist as we bring more products beyond DB SQL, right? So you might have heard many new products being now announced, some of them in public preview, some of them in GA for that matter. So we are introducing the ability for you to define your own egress control for serverless. And this provides egress controls around two surface areas, the internet and to storage, right? So think of it from your, if you're familiar with your own VNet or VPC, there is like typically two gateways, your NAT gateway and your S3 gateway or your service endpoints, right, on your network. So those are the two surface areas, and so we are providing egress control along both those surface areas over here. And why is that important? Because in the world of DB SQL, there was no egress to the internet at all by default, or there isn't there today, right? Second is, as I was mentioning, that the egress control is kind of baked into something like DB SQL, like because of the nature of it, like you are always going through our engine. But what happens when you start getting into things like notebooks and code? You can directly call some bucket if you wanted to. You can call Google Drive if you wanted to. All of that is available to you. So the objective of egress control is when you set it up and you go from this full access to restricted access, as you can see on the top right-hand side, it immediately locks you down to only UC paths by default. Now, what if not every path that you want to access is modeled in UC? Then we give you the ability to specify, okay, here are the locations on the internet where you want to grant access. Here are the locations on storage. Here are the storage buckets that you want to grant access. Ideally, you don't want to have anything here. That's our goal. Like, you should be able to model everything in Unity Catalog, and that's the only way for you to gain access. But we recognize that there might be exceptions there, and that's why we provide this capability. So this is in private preview right now. It's currently supported for model serving, and we are very aggressively working towards extending the support for all serverless products. So it's not like you have to configure it per product. You can just configure it once, attach it to your workspace, and it applies uniformly to your entire serverless platform. So that's, we've now covered all the three interfaces effectively. And if you want to learn more about our serverless security features, you can visit our Security and Trust Center, and that has a lot more information and more detailed documentation that you can use, perhaps even to have conversations with your, say, cloud security team. With that, I'll invite JP back again to help wrap up this presentation. Thank you.
Going forward, we're going to look at jobs that's coming up, serverless jobs. We're going to evaluate and again approve it for use, common use. And the other product is workflow that's coming in as well. So that's the next phase for us, serverless. Thank you.
Thanks, JP. As you can see, with Databricks Serverless, we have now met the scale, the security, and efficiency criteria that JP outlined for AT&T, and they are now in production, I believe with serverless SQL and also with model serving in production today, right? So that has been a great partnership and a successful venture thus far, and we're looking forward to, some of the biggest workloads on AT&T are like jobs and workflows, as JP was defining, and we're looking forward to that also moving to serverless over time, right? So if you would like to learn more and would like to join some of our previews, like the egress control that we talked about, please scan the code, and that gives you the ability. You can fill out a 10-second survey, and you can also, if you're interested in influencing a roadmap, this is also a way for you to provide input by registering here. So thank you very much for taking the time. I hope this was useful for you. If there are any questions, we can take them now.